Okay, so today we learned how to factor, and we started with GCF, and then we learned how to group, and then we learned how to factor a trinomial, and we learned how to do the difference of two squares. So GCF, you're just trying to find the greatest number that goes into both of them, and it has to be the highest, otherwise you won't be done. So on 18 and 27, the highest number that goes into both of those is going to be a 9. So 9 is going to come out because that's what the GCF is, and then you're basically doing the distributive property backwards. So you're asking yourself, 9 times what would give me 18x? And so 9 times 2 gives me 18, and then you need an x to get the 18x. And then you have the plus sign, and then you need 9 times what will give me 27, and that would be a 3. So this is now factored because the 9 got taken out as the greatest common factor. In number 2, they have a 4 as the greatest common factor, but they also have an x in common, so you do have to take out letters if they have letters in common as well. Then you open your parentheses, and you're going to put the leftovers. So 4x times what gives me x squared? I need an x to be able to make x squared. And then 4x times what gives me 8x? That would have to be a 2, because 4 times 2 gives me 8. When you have 3 or more terms, you also have to find the common terms of all the terms, not just the first couple. So between 9, 18, and 27, they have a 9 in common. And between x to the 4th, x to the 3rd, and x squared, they only have 2 in common. The second one doesn't have 4, and the third one doesn't have 4, but they all have 2. So now I'm going to have 3 terms inside, and I'm going to ask myself what's missing if I have 9x squared and I need 9x to the 4th. I'm missing 2 x's, so x squared. And then minus 9 times 2 gives me 18, and I have 2 x's outside. I need 1 more to make 3. Plus 9 times 3 gives me 27, and then I have 2 x's I don't need anymore. So that would give me 27x squared. With grouping, you're going to take the first 2 terms and figure out what they have in common, and then take the second 2 terms and figure out what they have in common, and then you're going to put the GCFs together and then the common terms together. So between these first 2, they have an x squared in common, leaving you with x minus 2. And between the second 2, they have a plus 5 in common, leaving you with x minus 2. Now if you notice, the insides right here are the same, and that's good. That should be. When you're grouping, that's what you want. So now, to write your answer, these 2, the GCFs, are going to be put together in one binomial. And then the 2 terms that were the leftovers, since they're the same, you're only going to write them one time. So your answer is just one of those x minus 2's times the x squared plus 5, not both of them. Okay, number 5, first 2 and the last 2. First 2 have an x squared in common, leaving you with x minus 3. The second 2 have a 4 in common, leaving with x minus 3. So notice the insides are the same, so now these 2 get put together, x squared plus 4, and then you have to put in x minus 3 as the answer also. Okay, number 6, the first 2 have an x squared in common, leaving you with x minus 1. And you take out everything, you have a 1 left over. And then the next 2 have a 2 in common, leaving with x minus 1 as well. So now the GCFs get put in one binomial, and then the x minus 1 gets written just once. Okay, the last ones are factoring trinomials. Remember that you're looking for 2 factors of c that add up to b. So we're wanting 2 numbers that multiply to give us 6, but those same 2 numbers have to add up to 5. And then you just make binomials out of them. So it ends up being 3 and 2. So x plus 3 and x plus 2 will be your final answer, because 3 times 2 gives me 6, but 3 plus 2 gives me 5. So you just write them as binomials, x plus the first number and x plus the second number. If one of the numbers had been negative, then it would be a x minus, not an x plus. So we need two factors of -6 that add up to a -1. So again, they're going to be 3 and 2, but one of them is going to have to be positive and one of them is going to have to be negative in order to make what we're looking for. So -3 and +2 gives you -6, and -3 plus 2 gives you -1. So that's those two. Two factors of -12 that add up to -1 is going to be a 4 and a 3 again. One negative, one positive. The 4 is going to have to be negative in order to make a -1. So x minus 4 and x plus 3. You can write those in a different order. Like you can put the x plus 3 first and then the x minus 4. So eventually we want you to get out of the habit of writing those, the what times what equals 15, what times what equals, or what plus what equals -8. We want you to be able to just come up with these in your head. Okay, like 15 is going to be 5 times 3, and both of them have to be negative in order to make a positive 15. So -5 and -3 gives you 15 when you multiply them, and then when you add them, they both give you -8. 45 and 14, 9 and 5, and both of them are going to have to be negative in order for them to be a positive 45. -15, you're going to have a -5 and a positive 3, one positive, one negative, to be able to make -15. And then -5 plus 3 is -2. All right, number 13, two factors of 2 that add up to 4 is impossible. So this would be considered a prime because 2 times 1 is the only factors of 2, and that cannot make a 4 no matter how you turn it. All right, 14 and 15 are our dots problems, our difference of two squares. You have to know your perfect squares. This is a perfect square of x. This is a perfect square of 10. So your answer is x plus 10 and x minus 10. You take both terms and you add them, and you take both terms and you subtract them. Number 15, this is a perfect square of 8. This is a perfect square of x. This is a perfect square of 9. So you're going to get 8x, that's the first term, plus the 9, and then 8x minus the 9. And that would be your final answer. Difference of two squares is meant to be done super quick. And we're done.